still? Okay, what we covered last week, if you remember. So last week we went over what is that data and computer communication, correct? So what's mean data and computer communication for us? Simply is exchange data. And to exchange data between system, which elements really you need? What is the 5 elements? Remember, we need
sender, receiver, and transmitter.
Media between them.
Yeah.
What else? Message. You are trying to send something, and the most
medium.
important, you need something to control that. What we call it, protocols. So you need the protocols to control the communication. Without controls, you will not be able to communicate, and you will not be able to make different ends to communicate and understand each other. So if you're making a computer if you buy a computer from Dell, still will be able to communicate with a computer from HP, because they follow, all of them follow the standard and protocols. So and we went over the history of the internet and network, how this starts in 1960, around 1960, with the Department of Defense as a project, and they've been able to connect 4 computers together. That's the first thing they've been able to connect computers to. You know, with the time, they start building protocols, and they enhance that, and they finally got to kind of a standard, the TCP/IP, which we use. Without the TCP/IP, we will not be able to use computers. All right, so what's today class will be? It's going to be a challenge for you guys today because we don't have, but I'm recording the class today, so I will post it on YouTube so you can review that. So let me go over chapter 2. So what we will discuss in this chapter, I'm sorry guys, you will not see that, but the people over Zoom, they can see. They are lucky today. All right. So what we will learn this one, we will discuss the multi-layer protocols. And what is the concept of the multi-layer? Why, when we have a problem, you know, we divide it 2 layers, not try to solve the problem, you know, in 1 layer. That's because it's going to make it more easier when we divide it to small layers, and you can control each layer in separate protocol. And we will discuss the first you know, standard, which is the OSI model, which has, yeah, you can mute that. So which has, you know, if you have your phone or iPad or laptop, you can access the, you know, documentation or the slide there. So after that, we'll go over the OSI model. Is the first model we use in networking, and how many layers? Has 7 layers. So keep that in your mind. Then after that, we'll discuss. We'll go over, of course, OSI model. Then we'll go over the most. So we'll go to the most important, you know, standard, which is the TCP/IP. So all the network now using TCP/IP protocol. And we'll go over each layer in the TCP/IP protocol, and we'll see that. And the last point, we will cover the addressing. So how you, when you try to communicate, you need an address. For example, if you're trying to send a mail to somebody, so what you need the home address, you need the street name, you need the zip code, you need the country, the state. So we will see what type of addresses we are using to communicate. All right, so in chapter 1, we discussed that we need a standard, we need the protocols. Without that, we will not be able to understand each other. So for example, now I'm trying to explain something to you. If you are talking at the same time, that will not work, because you cannot both of us talk in the same time. So somebody will talk, the other end will listen. And if you talk, I have to listen. So we have to set these rules, you know, that's a simple rule just to communicate. And we have to follow this rule. In this case, multiple hosts or multiple computers, they can communicate without any problem. And again, why, if you want to use the communication just only in one simple protocol, it's going to be a challenge. So that's why we divide it to multiple protocols. That's why when you go to the network layer, you will hear something called IP protocol. You will hear about the ARP protocol. Then when you go to the transport layer, you will hear something called TCP protocol and UDP protocol. And we will see what's the difference in the future, you know, after a few weeks. And when you go to the network layer, you will hear something called HTTP protocol, you know, SMTP protocol for mail, FTP for transfer file. So that's why you divide your problem or the communication to sub-layer, and each layer provide a service, and we'll go over that. Now, for example, let's go to a simple example in our life. Let's say, you know, we have two person. Okay, we have Liz, she speaks Spanish, and we have you know, what's my manager name? Elizabeth. She speaks English. Okay, so they are a friend and they like each other, and when they meet, they communicate. But now one of them speak Spanish and one speak English. So how they will talk to each other? No, so they lucky, both of them, they know the sign language. So they are now they communicate, they use the sign language because they know how to use the light language. So they using the sign language as a protocol, correct? Now, if we change that, okay, if you know one of them decide to move to another city or another state, okay, and they still a friend and they want to talk, and when they met the last day, okay, Liz brought two devices with her. One device transfer or translate the letter from English to Spanish, and the other device translate from Spanish to English. So she gave Elizabeth a device, and she kept a device with her. So now she traveled. She went to another country, another state. Now, how they will be able to communicate? So what they will do? Let's say now Liz will send a mail to Elizabeth. She will write a letter in Spanish, correct? And she will use the device to translate that to a secret code. Then she send it, put it in an envelope, and send it out using the post office, correct? And when the letter reached to the other destination, reached to another country, the mailman will deliver to Elizabeth's house. Elizabeth, what will do? We grab the letter, put in the device, which it will translate from Spanish to English, and then Elizabeth will understand the letter. So in this scenario, what we did, we divided the problem to layers. So the first layer is how write the letter. Second layer to translate it. Third layer is to send it out. Okay. So at the other end is the opposite. I receive the letter, then I translate it, then I read it. So you do the opposite. So what we did to simply, you know, break this problem to a simple, you know, layers is to divide to multiple layers. So the same thing for network. So network, if you're trying to send a message from computer A to B, all right, you know, you have to divide it to multiple layers, and each layer will give you a service, will give you a function, and we'll see how these layers will work. Okay, so the point here, you have to make your communication simple by dividing the, you know, the communication to multiple layers, and we'll see that. All right. So here, now you have two sides. You have computer A and computer B. So computer A do a specific function. Now computer B has to do the same function, has to be able to do that. So when you send a letter, you write it, At the other end, you should be able to read it. So kind of the opposite operation you do. And when we send a message through the network, what we do, you know, if for example, I'm trying to browse Google website. So you type Google website, then the your request is gonna go to layer after layer, then until goes out. At the other end, you know, when I receive the message, I will start reading the message, move to layer from layer to layer until I reach out to the what I need. Now, the opposite is gonna happen. If computer B will send the information from B to A, so he has to do the same function. So you have to have the ability to do both sides. So if you do a specific function here, you have to same thing, you have to do it in the other side. So that's why when you have two computers, they will have the same layers. You will have application, transport, and network, and we'll show you now. We'll go over it. So I'm trying to just play with this device. Hopefully, it's gonna kick in somehow. Now, each layer. So let's say you have 5 layers. Okay. So each layer will provide a service to the layer, either the above layer or the below layer, correct? So each layer has a function. We'll provide it to one of the layers, either the above or the below. And we will see how that's gonna look like. So now the first standard came in around 1947. There is an organization called ISO, International Standard Organization, ISO. It's this standard organization. It's built with multiple bodies, like organization work together to put the standard, and they came with something called OSI model in 1970. And the OSI model stands for what? Can you guess? Correct. Open System Interconnect. So Open System Interconnect. That's the first standard came. Actually, TCP/IP started before that, but become an official one after the OSI model. So in the exam, if I give you a question about what is the difference between the ISO and the OIS model, what's the difference between them? You don't have to read. What's the difference between the ISO and OSI model? So the ISO is an organization, and the OIS model is OSI model is standard. So that's gonna come in the exam. That's one of the questions. So to remember that, multiple choice or true false. Okay. Clear so far? You can, if you have a question, ask me. All right. So open system, it's a set of protocols that allow any two different systems to communicate regardless their underlying architecture. Okay, as we mentioned before, if you follow the same standard, computer built by Dell will be able to communicate with computer built by HP, correct? Computer using the wireless card will be able to communicate with a computer using the Ethernet. Computer using Ethernet card will be able to communicate with a computer using token bus, for example. All right. So since all these manufacturers follow the standard, you will not have an issue to communicate. So they will understand each other. All right. As we mentioned, different hardware doesn't matter. Still, you can communicate, and yeah, it's the same concept. So now let's go over. Hopefully, that's gonna show. No. Okay. So the OSI model has 7 layers, correct? Keep that in mind. I will repeat that a lot. The OSI model has 7 layers, okay? And these layers are from the bottom to top, okay? Let's remember that. So the first layer is, anybody knows? Physical. What is the physical? What is the physical layer presented by? The physical is the media. So which type of media we are using these days? Can you give me an example? Wireless, correct? Wi-Fi, wireless. And there is too many types of the wireless. For example, Wi-Fi, infrared, Bluetooth, all this type of the wireless, correct? What else? Wireless, what's the opposite of the wireless? Cable, wire media, all right? And what's the, can you give an example, some of the wire media we are using these days? That's for networking? That's not for networking, that's for display. UTB, the Ethernet cable, we call it UTB. Yes. And what else? What we are using for our internet? Cable, correct? Cable, and this cable we call it LAN. What you said? We call it coax cable, right? And you have fiber optic. There's too many different types, but the point here, physical is responsible for what? Is to send the data through a media, okay? And we will go over it now. We'll give you more details. What is the second layer? Is data link layer. Physical, then data link layer. So what is the data link layer do? Again, remember, each layer will do a function, or maybe set of function, maybe 1 or 2 or 3 functions. So data link layer is do a function and do a specific function. And data link layer provide a service to physical, correct? And what is the data link layer do? Is dividing the message is coming from the layer above to a small packet. So when you're trying to send a message through the cable, you're not sending the whole message at once because it's big. So you have to divide it to a small pieces. And data link layer is responsible to divide it to a small pieces. What we call it? Frames, right? So at the data link layer, the data type or the data name, we call it frame, correct? What at the physical layer, what we call it? How we send the data through the cable. How we send it. First of all, the computer, how the computer work. Which type of data we are using in the computer? 0 and, correct? Now, when you send the 0, 1 out, how you send it? What type of signal you are using? Digital, but binary, for example. But now, when you send it through the cable, it's going as 0, 1, 0, 1. Converted to, correct. It's going to be converted to signal. So when you send any data through the cable, it's going to be signal. So in the computer, it will be digital. Then you have to convert it to a signal and send it out. How we convert it to a signal? Using coder, correct? So you have to code it from digital. So for example, how is the 0? Now in digital, how we do the data? If you have 0, 1 and 0, how that's in digital, it's going to look like? It's going to look 0, 1, 0, correct? Now, when you send that out using the cable or the Wi-Fi, how we send? You have to use it just as a signal. Somehow, you know. So there is different type of signal. You can use the frequency, you know, or the value. So for example, frequency signal. If it's too close like this, let's say that we say that's 0, and if it's big, let's say that's 1. All right. Now that's if you want to use the frequency. Now, some of them you use the amplitude. So, for example, let's say that's 0, correct? Now, let's say if it's 1, that's if the value, I'm sorry, this 1 and that's -1. If the value is 1, that's represent 1. If the value -1, that's represent by that's 0, correct? So for example, if you're trying to send 0, 0, 0, 1, how you send that? going to be something. It's going to look like 0, 0, then 1. All right. Then the other end will understand what this one. Other end will translate it to 0, 0, then 1. All right. So that's not our course, but I'm telling you how the signal. So when you're trying to send a signal outside, you have to translate it from digital to analog or to signal, and you will use the decoder. And what's the data type we call it, or we call it bits. We send bit by bit. We send 0, 1, 0, 1. So the data type, we call it bit. That's at the physical layer. At the data link layer, what we call it? Frame. Correct? So one of the function on the data link layer is to divide the packet to frames and send one by one. And we will go over all the functions. What is the third layer? Network layer. And network layer, we use a famous protocol, which is the IP protocol. And we will see what's this protocol do. And the data there, we call it packet, and we'll see. Then what is the fourth layer is the transport layer. And what we call the data there, session or segment. I'm sorry, segment. And again, transport layer will do a specific function. I will learn that. Then after that, we'll have layer number 5 is session, then presentation and application. So what is the first layer? Physical. That's very important. The exam first for the midterm exam, it will be about TCP/IP and OSI model. You know, what is how many layers, what is function of each layer, what the name of the data there. It's really simple exam, but you have to remember that. Maybe it's gonna confuse you at the beginning, but you have to remember all this information. So physical, data, network, transport, presentation, and application. So 7 layers. Is there any question so far? Yeah, I don't know how all this stuff, you know, without presentation, it's gonna be tough. Now, let me try to do that. I will try to draw a few things, you know, try to explain. So let's say I have computer A and you have computer B. Perfect. And usually the computers, it's connected through a network. So it has to go through a switch or router, right? Unless if you have the computers connected by cable directly. However, most of the time you will have either a switch or router between them, all right? So if you want to send something to B, it has to go through the first router, then from to the second router, then to the third router, okay? So how many layers do we have here? We have application, then presentation, then session, transport layer, then network layer. Which one? Data link and physical. Okay, 7. And the same thing here. You will have the same application, BS, then T, then network layer, then data link, then physical. Okay, so that's what you will have. Now, that's at the computers. Okay. What about the router? The router, how many layers has? Remember, the router is not a computer. It's just a device connecting computers together somehow. So on the router, usually we call it R. Okay, let's say R1, R2. So in the router, usually you have only 3 layers. You have physical, you have data link, and you have network. Same thing, this one will have network, you will have data link, and you will have physical, correct? Now, if you want to send a message from A to B, which path I have to follow? How the message is gonna transfer from here, from A to B? How?
We start with the physical layer first.
Okay.
Router.
So first of all, the message comes from where? Usually from the application. Okay. Let's say you're trying to browse to Google. So what you do, HTTP, colon, then do Google, correct? .com. So that's at the application layer. So how the actual data is gonna flow, it will go from here, right? This way. Then from physical will send it to this physical. Then how this one will go? From here.
Next.
Where? So it has to go up. All right. Then what I will do, then from here, it's gonna go. I'm sorry, it's not gonna go physical now. It has to go down. Then through the physical, it's gonna go to the next hub. Then here, it will go up, and it's gonna go down. Then it's gonna go to the destination, and then it's gonna move all the way to the application. Then you will see your page. All right. So that's the actual physical path. All right. So if you want to send anything, it has to go through each layer. It has to pass one by one, and go through the cable or through wireless. Then when the router receive it, it will open the packet again, and move it up. Network layer will do something. We'll learn it later. Then we'll send it back. Then continue. All right. So that's how the actual path for the data, how the data goes through the network. Now, that's what we call this connection. That's the physical connection, and that's usually what's happened. However, there is something we call a logical connection, which is between both similar layers. So the application here, there is a connection between them, all right? But that's logical, which is mean the application layer here, in their mind, so I have a connection with the other application layer, but there is no actual connection. There is no cable connecting between them. Still, the data has to flow through the physical path. All right. So remember that in the network, we have two connections. We have a physical connection, and we have a logical between similar layers. So, which is mean you have a logical here, and you have another one here. You have another one here. All right. Then, and same thing for transport layer. Then here you will have one here. You will have one. I'm sorry, guys. We'll have another. There is a logical connection. There's a logical connection, correct? All right. That's the logical connection. Clear so far? Is there any question before we continue? Okay, another concept. What is the difference between router and switch? So switch, we will learn it in a few weeks. The switch only work in that two levels. The switch only goes up to data link layer. So switch has only two layers. Router has 3 layers. Okay. All right. So as we said before, each layer will ask for a service from the layer above, or give a service to the layer below. So always there is a service. Each layer do a function, and we will see some of this function. All right. As we said, layer to layer communication, or that's the logical, and you will have the interface between layers. Okay, I'm sorry. Now the connection between this layer and layer, these two layers, there is an interface. So that's how they communicate. They communicate to each other using interfaces. So you will have an interface between A and presentation, from application or presentation. And there is another interface between the presentation to session. Is there an interface between application and session? No. Okay, why? Why there is no any relation between or connection between these two? All right, so the reason why they do that. For example, if you work in this layer, you're trying to enhance, you're trying to do a new application. All right. So what you will care about really, you will not care about anything else. You will care only about this one, because that's the direct connection. So you have to follow all the standard for the presentation. You don't have to worry about the other stuff. So that's why you divide your problem to multiple layers. So if you're focused in your research, for example, at the application layer, you don't have to learn everything here. You don't have to go crazy about that. Just focus on the presentation, because that's what you worry about. Understand the presentation very well. Understand all the protocols. What you need. Can you mute yourself, please? All right. Yes, do you have a question?
Satish, please unmute.
Mute yourself, please. All right, so now let's go over the so now let's say I have a message. I'm trying to send a message from the application. I want to send a message from host A to host B. I say I'm trying to send a message, I love UB. All right. So this message has to go through all these layers. So that's the actual message. Right? We have a concept called encapsulation or capsulation. What is the capsulation? Capsulation, you put your data on in a box, for example, and you add something and you pass it to the next layer. So for example, I'm trying to send out. So what I have to do, okay, I will write it this side. I will add header 7. All right. So I encapsulate it, then I add a header. This header has a lot of useful information. Like the address for the destination, the port number. There is a lot of things you added to the H7. Okay, we call it H7 because we are in this layer 7, right? Now, then what's going to happen in that presentation layer? What's going to happen here? So I will take the whole thing. This is the whole thing as the new data here. So what's my data? It's going to look like? It's going to look like I love UB and H7. So this one is not going to look like this. It's going to look like one message. All right. It's going to look like one message. However, we show it like this, but it's going to be one message. Then what this layer will do, will add another header. Again, this header has information, more information, which you need, correct? And we will learn that. Then what's going to happen here? Now the message will get even bigger. All right, so the whole thing here will come as data now. Then what we will add here? H5. You will keep doing that until you get the last layer. You will have a bigger message or data, and you will add H1. All right. All right. So after that, when I send this one here, what's going to happen? I will do the opposite. So what I received here, so you receive the data, and you have H1. So what you will do, you will delete this one. Not delete it, you read it, you remove it, and you use the data inside for a reason. Then you move it up. Then in this layer, what you will have the data and H2. There's no 6. Then here it will go up. You will delete this one. It's gonna be the data and H3, right? Then what's gonna happen there? You will remove that. Then you transfer it to this side. This one, it's gonna look like? You will do data, then add a new header H3. Right? We'll see that now. So then the same thing. It's gonna go there. This one it's gonna be your new data. Then you will add the header 2. Then in this physical layer, you put it together, add a new header, and send it to next hub. This hub will do the same thing. Open it, remove H1, move it up. Open it, remove H2, move it up. Open it, read it, remove H3, do specific thing, then add H3, the new one, and we'll see what's the new one is gonna look like. Then you send it. Then it's next hub will do the same thing. So that's the encapsulation and encapsulation. Clear? Is there a question about capsulation and encapsulation? Good. You know, if I have the presentation, it's 1 minute to explain it for you. It's already there. I just have to hit next. Oh, guys, I don't know, guys, if you can see that. I don't know. Let's see if you can. Give me 1 second. So, can you see? If you're trying to send it from A to B, so the packet as D7, that's the message. You add H7, then goes to D6, add the H6, D5, you add the H5. So your message getting bigger and bigger because you keep adding header to it. So when it's got to the physical, what's gonna happen? It's gonna send it 0, 0, 0 to the network. After that, then when the other side receive it, we'll do the opposite. It's gonna be a big message. Then you start removing header one by one until you have the initial message. Okay. All right. Clear so far? Now let's discuss each layer. Let's go over each layer one by one. Okay, let's go about physical layer. What's the physical layer do? It just send the bit stream, send 1, 0, 1 by 1, correct? Just sending, that's the job of the physical layer. It's just really a cable. There is nothing much there. Cable or the air. If it's Wi-Fi, it's the air. All right. So what is the physical layer really care about? What you have to know to decide what's your network is gonna look like. What's the physical care about? So first of all, you have to know the representation of the 0 and 1. As I explained before, how the 0 and 1, are we using the frequency, or we are using the amplitude, or we are using different ones? So we have to understand which way you will send your data. Second thing, the data rate is very important. Let's say you're using the UTP cable. Okay, you have to know how much this cable can handle. All right. So if this cable can handle only 100 bit per second, you cannot send a message with 1,000 bit per second. All right. The cable will not be able to handle that. So you have to know what is the data rate for this cable. The other thing, the synchronization bit, it's very important. What is the synchronization? you have to sync both ends, A and B, to know when you can send. Are B ready to receive? If the B is not ready, then you cannot send, you have to wait. So it has to be synced. What else we will have? You have to understand, you know, the connection between A and B. Is that point to point? It's only a direct connection, is not going through routers, because that's gonna change that setting. Is this one multi-point, like, you know, you send from computer A and computer B, it's connected to to a network has multiple node? Or what about the transmission mode? We explained that last week. Remember, we explained the transmission mode. We have a simple communication, which is one direction. Computer A send to B, B cannot send back. Or you have the half duplex, which is A can send and B can send, but they cannot send in the same time. So if I'm sending A, I'm sending to B, B has to wait. When I finish, then B can send back, all right? Or it's a full duplex, which is mean I can send in the same time. I send and receive in the same time. So you have to know all this stuff, you know, to be able to customize your network or the communication. Without knowing that, you will not be able to do, you know, a right communication. For example, if multiple computers are trying to send in the same time, and there is no a control or somehow to control that or work flow control, what you will have a conjunction in the network. You will get to the point the signal mixed together and it's going to be corrupted. You know, you will receive a wrong message. So that's why you need a flow control, and we'll discuss that. So that's physical. Okay, what's the physical layer responsible for? Moving. So moving the individual bits from one node to the next one. Again, when you're moving, you care about the next hub. So I'm moving the stuff. Even I'm trying to send it to B, but physical will send it to router 1. That's the job. The router 1, physical layer of the router 1 will send it to the router 2. So physical layer responsible only hub to hub, from computer A to the hub, or from the hub to hub. So only the area between them. Okay, you are not, the physical not responsible to send the data from A to the B. It's going to be part of each hub responsibility to deliver that. All right, what else we have? Data link layer. I will try to go fast because I think we are behind. So as we mentioned, data link layer, it's stay in the top of physical. Okay, physical is not, there is no any protocol in physical layer. So you need something above that physical to control the communication, which is data link layer. So what is data link layer do? As we said, fragmentation, not fragmentations, framing. So because we said, you know, it's frame, the data on the data link layer is a frame. If you have a big message, when the packet is coming from the network layer, comes as a packet. However, you cannot send the packet. When we start explaining the protocols, packet is too big, so you have to divide it to frames, and you send it frame by frame. So one of the function for data link layer, framing. What else? Physical address. So if you want to send anything, you need an address. So the first address we will use is the physical address, or we call it MAC address. So data link layer is responsible to find the actual physical address for your computer. What else? Flow control. What's the flow control? It's a very important function. Why we need a flow control? Because you don't want to overwhelm the destination. As we said, if host speed is slow, okay, you have to slow down. Let's say, you know, you have a strong computer, fast speed computer, but you're trying to send it to A, to host B, and host B is slow. Then what you have to do? You have to send slowly. You fast, but the other end is slow. You have to control your flow. Error control. What's the error control? Data link layer do? So again, as we explained last week, when you send a data and for some reason the data got corrupted, what you have to do?
Resend that.
Resend. Okay, what about if you lose the acknowledge?
Will send the
Resend, but there is a protocol, so you have to understand, you have to follow the steps. All right, so data link layer again is responsible to do error control. If you lose packet, if you have a corrupted, then you have to resend it. So that's one of the function. What about access control? Another function is access control. What do we mean by that? We just explained that, access control. If you have a multiple computers using the same network, then you have to give access, to the device, not all of them at the same time. You have to do it one by one. If you have A, B, C, so I give access to A to send, then I give B access to send, then C. You cannot give all of them access in the same time. All right. So that's some of the function of the data link layer. So the exam, I will ask you, select some of the function of the data link layer. Let's do it quickly. Framing, flow control, error control, access control, physical address. Simple. All right. So that's one question in the exam. I'm serious, really. What I tell you, it's coming in the exam, it's gonna come in the exam. All right. Third layer. What's the third layer? Network layer. What's the function of the? So network layer use something called IB protocol, and we'll explain that in chapter 9. IB protocol is very important protocol. However, IB protocol is on what? So network layer is using the IP protocol, which is unreliable. So you cannot rely on that. So, and we'll see it later. So IP address is just building the packet and send it. Will not do error control or flow control, nothing. All right, that's why we need the transport layer on the top of that to control that, right? So what is the function of the network layer? Is logic address. What is the logic address? Or IP address, what we know, correct? So each computer will have IP address, correct? That's the way how we communicate. Physical address is the actual hardware. It's the MAC address, which is printed on the network card, correct? Logical address from the name, it's logic, So my name, my name is Muhammad, but I go with Mac. So people, they call me Mac, all right? But when they're trying to send me a message to my address, they will put my name, Muhammad. They will not put Mac. They will use my actual physical. So one of the function is logical address. And what is the other function of the network? Routing, correct? As we mentioned here, correct? So remember the third layer? Network layer is responsible to route your data from hub to hub until you get to the destination. So two functions of the network layer: logical address and routing. Good. Next layer. What's the next layer? Transport layer. Transport layer is very, very important layer. Why? Why transport layer is very important? Because we said network layer is unreliable, correct? You cannot rely on that. So that's why we need a layer on the top of the IB or network layer to do the error control, the flow control, all the other stuff. So and the transport layer, we call it process to process. What does it mean, process? Process to process. So again, transport layer, it goes to the other end. There is no transport layer on the router side, correct? What does it mean, a process to process? So process to process, it's mean transport layer has to make sure the whole message, remember the message we divided to small pieces? We have to make sure the the whole message got received here. And it's in the right order. Network layer what's the job of the network layer? We will build a packet and send it. Okay, and network layer will not give you which path you will go. So network layer, maybe if you have, let me do that. It's gonna, we'll explain it again, but let's see. So let's say you have a host A, you have host B. Okay, let's say you have R1, R2, R3, right? So and everything is connected somehow, and maybe this way, maybe this way. Okay, let's say that's the network. That's your network. So at the network layer, you have a packet, like packet 1. You try to send that. So based on the network and the traffic, maybe packet 1 is gonna go this way. All right. Then you're trying to send packet 2. Maybe packet 2 will go this way for a reason, right? Now that's packet 1 and that's packet 2. Now at this end, so based on the traffic, maybe packet 2 will receive before packet 1, right? So a network layer, we will not organize it. Just will send it, and network layer here will just will receive. However, the transport layer, when they receive the whole thing, when let's say you have up to 10 packets, and you will receive it. Let's say that's B10, and then B3, then B9, and you receive all of them. Transport layer, what we'll do? We'll put them in order. B10, one message, and then pass it to the layer above. That's why we call it process to process. So transport layer is responsible to make sure we receive the whole message in the right order. Okay? Network layer, no. I don't care if you receive in order or not. All right, so what other thing, in the transport layer, you need the port address. And we'll explain that later. We'll do segmentation and reassembly. Remember the message, when the message comes from here, you have to segment it to a small ones. That's called segmentation. And when you assemble, you put it together, you put them in the right order, okay? So when you do segmentation, you do segment 1, segment 2, segment 3. All right, then you send them. Then when you receive them at the end, it will be segment 3, segment 2, segment 0, for example. Then you put them in the right order. Then you pass it to the layer above. All right. So that's segmentation and reassembly. Then, as we say, connection control. You have to control the connection, and you will have a flow control in this layer, and you will have an error control. That's why it's very, very important. TCP is very, very, very important protocol. That's what we call it, TCP/IP. Clear? What is the next session? Next layer is session layer. And what is the session layer do? It's open dialogue between two computers. What we mean by that? So let's say you have a computer. You open your browser. You go to cnn.com. Okay, that's my computer A. Right? And what you will have here? You have internet, correct? Internet, correct? And you open a browser, correct, to the CNN. Perfect. So in the same time, you open another tab. So the same computer, you go to the CNN, open another tab and open CNN, right? Let's say you are at the CNN, you are in the news page. And this one here is sport. Right? So now if the data, if you communicate between your computer and CNN with multiple tabs or multiple sessions, and they send the data back, how your computer will know this data coming back, it's about the news page or the sport page. So the session layer will control that. So each connection is kind of a separate session. So when the data is sent back, it will know or which tab, the data has to go back, right? So that's the session. If you open multiple sessions, and for example, even the CNN, like when a million people trying to access CNN web page. So the CNN, how would CNN will know which which computer has to go through the session layer. All right. The other very important point is that synchronization. What is the synchronization? It's very important. So for example, you're trying to access a web page or a document. So this document, this document has 5,000 pages. Perfect. Right. So you start reading, you're loading 10 page by 10 page. So for example, I start read and I start with the first 10 page, start with the 20, and I reach out to 420 pages, correct? Now, for some reason, you lost connection here. Now, what do you have to do again? You have to start from scratch, right? However, if you have a synchronization point, let's say, every 10 pages I read, I will add a flag, correct? Then I first 10, then 20. All right. Then for some reason I reach up to the 420. Then at page 429, I lost connection. Now what's gonna happen? Which one I have to hold for? Which one I have to read? Do you think I have to go back all the way here? So I will go back only to 420. So I have to load only 9 pages. That's the pages I lost, right? So that's why if you keep adding points, checkpoints every time, then you don't have to lose the whole data. You don't have to go back all the way to the beginning. You can go back to the last check. All right? That's in that session layer. That's very important function. All right. Presentation layer. It's easy layer. Presentation, the presentation focus on the semantic and the syntax of the message. So if you want to do encryption, you do it at this layer. If you want to do translation, you do it there. If you want to do compression, what's the compression? What's the function of compression? You compress your data, correct? If you have a big data, there is somehow you compress that. So when you send it, it's gonna be faster. What's encryption? Why we need encryption? Secure the data. You don't need somebody else to grab your packet and read it. And translation, it's clear to translate it. Okay. Okay, application layer. What is the application layer? Is the user interface, correct? That's what's the user will not access the TCP transport or session. User will do application, HTTP if I want to browse a page. What else? File transfer. I want to send file. I will use FTP protocol. What else? Email. What type of protocols I use when I trying to send an email? STMP. Correct. What about VPN if you want to access a remote network? So it's application layer. That's the interface for the users. Okay. Is there a question about layers? That's the last one, correct? All right, so let's go very quick. Physical, I will just read it, guys, for you. To transmit bits over the medium, to provide mechanical and electrical specifications. Data link layer, what's the data link layer do? Organize the bit into frames, correct? And to provide hub-to-hub delivery. Data link layer cares only about the next hub. That's what I care about. I don't care about the destination. Okay, network layer to move packets from source to destination, to provide the interconnect work. That's it. Transport layer, it's a process to process and make sure the delivery error free. Make sure there is no error. Session to establish, manage, and terminate sessions. If you have a multiple session, that's session layer. Presentation, if you want to do translate, encryption, and compression. Okay. And the first and the last one, it's application. What's application do? Allow access to the network. That's that's the function of the application. All right. So what's the time now? Okay. Do you need guys a break 5 minutes, or you need me to continue? Let's take 5 minutes. Now, when I go over TCP/IP, it's going to be quicker because almost the similar, less layers, but almost the same function. So I want to speed. If you want to take a break, take a break. If you have a question, ask me. I'm here. Guys, you didn't need a break? Or you asked for a break. Are you guys, all of you, undergrad or graduate? How many undergrad here? 3, 4, 5. Wow. That's the first time I see undergrad in my class. And this course, I mean. Yeah, because that's level 500, correct? It's required for you? Wow, okay. Are you sure? Not 472?
Yeah, I think there's like this course is listed under the requirements, but it's not being offered. So this course is equivalent. So they told us that
Oh, so 472, it's required for you. Yes. Yes, yes. Because yeah, usually 500 is for grad students, but this course it's easier than 472. So you're lucky you got this one. Yeah. So I'm planning to teach 472, but still I have to review it because I think that's more of the configuration for the actual router and switches. Yeah. So
how would the exam be this class?
oh, I explained that you missed the first class, correct? Okay, you join online. Okay, so all right, so let me explain that to you. So the exam will be actually they assigned a GA for me, but he did not come. But I will ask him to join. So we have a GA. I want to share his information with you. So the exam will be midterm and final, and assignment. Assignment usually it's 10 points, and maybe we'll give you some lab, Wireshark lab. It's really something easy, simple. So maybe 10 for assignment, 10 for the lab, and 40 for the midterm and 40 for the final.
For the exam, I'm just curious because we have a very big class size, but there's probably not enough seats.
It will be over the computer. Okay. We will use the what they call it. Oh, actually, I mentioned that to you guys, correct? Make sure you to install the lockdown browser, correct? Did you use that before, guys? Lockdown. So make sure you have it ready. In the exam, I'm not responsible when you start the exam. If you don't call me, say, no, I cannot do the exam, my session, my camera is not working, because you have to make sure your camera is working fine, your mic working fine. Because if your camera or the mic is not working, you want to be able to start the exam. All right? Because we have this function when you're in the front of the computer and do the exam. If you do any movement, it's gonna track your movement. If you talk or if you use a phone, it will track that, and it's gonna send me a notification. Then I can go and review. So it's very important to know that it's not gonna be in this place. It's gonna be from home. It's gonna be a multiple choice. Usually around 60 to 70 questions, multiple choice. It's easy, but you have to study. You have 2 minutes, guys. You already spent the 3 minutes.
You said 11 minutes, right?
I said 5 minutes.
Oh, I'll be back.
Okay. It's already. And the other thing, try to go to Canvas and do more practice there, because Canvas is gonna show me who spent more time on the Canvas reading and studying, and that's very important. All right. Ooh.